As we get back on our lectures of the properties of colloids, in our last video we have discussed about the kinetic property of colloids. In today's video we will be talking about the optical property, which is rather a very amusing property of a colloidal solution. It is mostly known as Tyndall effect. As you can see, that when we use a torch and we put some light inside a true solution, which is actually the solution that we have been reading since we were a kid, we can't see the path of the light inside the solution. You see there is blank, and the path passes through it and we can see it again afterwards. But when we use that light and we pass through it inside a colloidal solution, what happens is that due to the scattering property of light, we can see the path of the light inside the colloidal solution. Scattering happens because the colloidal particle are a bit larger than the particle that exists in true solution. As what happens is that the light deflects inside those big particles and it reflects towards to our eyes, and we can clearly see the visual path of the light. And this property of colloid is known as the Tyndall effect. We can see some examples here. As you can see, the light coming from the window and the light in a jungle. All of this happens due to the scattering, And if we see exam ready note for this Tyndall effect, the exam ready definition of it is that Tyndall effect is the phenomenon of scattering of light by colloidal particles when a beam of light passes through a colloidal solution, making the path of light visible. And the reason why Tyndall effect happens is firstly because colloidal particles basically have the same size, or a size that is comparable to the wavelength of visible light. The particle size is somewhere equal the wavelength of light. And when the light strikes this particle, it gets scattered. Scattering is a property of light where the light deflects in different direction. And as this scattered light reaches our eye, we see the light path. And there is a chart which might help you build proper intuition regarding this, why different solutions show and not show Tyndall effect. We can see that true solutions, due to its particle size, do not have any Tyndall effect. Colloidal solution having medium size particle, very similar to the wavelength of light, creates colloidal Tyndall effect. And the suspension solution, due to having large size particle, it blocks the light and it doesn't scatter, it literally blocks away the light, so we cannot see the light path as well. And the importance of Tyndall effect is that we can distinguish colloids from true solutions. We can literally test whether colloids are present or not. And it's also used in ultra microscopy, and that's how it is the optical property of a colloidal solution. So that's all I had to say. I hope it helps. See you in the next video.